So already I told that airfoil will have one lift, one drag. Okay. So parallel to CD maybe or FD, FL, force, lift force, drag force. Okay. So our target should be to reduce drag force, increase lift force, so that for example aircraft, it will be moving up. Okay. So let's draw one airplane wing. So this is airplane, and airplane, if you look properly, this is actually airfoil shaped. All the airplane will have this. If I take the cross section of a wing, it will look like this. Okay. So these are called airfoil shaped. Next time you fly by airplane, so just you look at it, airfoil shaped. Okay. And many airfoil connected together, it becoming whole wing. Okay. And this is leading edge, this is trailing edge, TE. I am writing short form, trailing edge for TE, leading edge for LE. Now whenever I am talking about pressure surface, suction surface, so lift force, this side will be pressure surface, actually pressure surface. So pressure surface side, I will have higher pressure, my pressure will be lower. Sorry, this is suction pressure, suction surface. This is suction surface, so P will be lower, pressure will be lower, and velocity will be higher, fluid velocity will be higher. But suction surface, this is pressure surface. Pressure surface, P will be higher, velocity will be lower. Okay. When airfoil generates lifts, it deflects air downward. Okay, you see airfoil, when fluid is flowing over it, it is deflecting air downward actually. Okay, so when it is deflecting air downward, what will happen? Air will be pushing the airfoil up so that air can move at straight path. Okay, so air will try like this. Air or any fluid will be trying to lifting up the airfoil or hydrofoil. Okay. So airfoil will be moving downward, will be forcing downward. So the airfoil will be giving downward force to air, and air will be giving upward force to airfoil. Okay. So equal and opposite force should be upward on the airfoil. So both force will be balanced. So in that way, you are getting lift actually. Okay. Angle of attack. So another term will be coming, angle of attack. So first, another term you have to remember, leading edge to trailing edge connection, this straight line is called chord line. Okay. And another line will be there, camber line. I'll write on better airfoil here. Okay. So one line will be there, just average of upper surface and lower surface, called camber line. Okay. So another line will be like this, straight line connecting to leading edge, trailing edge, A to B maybe. So this is called chord line. Okay. So the angle of attack means fluid direction is here, my chord line is here. So flow direction is this one. This angle is called angle of attack. Okay. So angle of attack should be proper. For example, 5-10 degree angle, 15 degree maximum possibly, angle of attack will be optimal. If very low angle of attack is there, you will get more drag. If very high angle of attack is there, maybe there will be flow separation. What is flow separation? Flow separation is that whenever airfoil is moving in air or air is moving over airfoil, so both are same actually, air is moving over airfoil or airfoil moving inside air, both are same. So in that case, let's say initially my air is like this, Okay, it is touching whole surface, there is no flow separation, but my angle of attack increase or flow velocity increases at very high rate. So what will happen? So fluid will be moving, and at certain stage there will be lots of vortex will be created. Okay, so this is flow separation. Okay, so whenever any airfoil is designed, the scientists will be considering this flow separation point. If flow is getting separated quickly, then it will not get lift. Rather, let's say airplane moving up and you make very large angle, nose angle. So in that case, flow will be separated and flight will be falling down quickly. Okay, so that's why flight, whenever it is going through runway to lift it up, so it will have proper angle. If it is not having proper angle, or it is not getting proper angle of attack actually, so then what will happen? This flight can fall down quickly. Okay, so you should have optimal angle of attack, then you will get proper lift. So whenever you are designing turbine also having airfoil, so turbine airfoil also should have proper angle. Okay, so if you have proper angle, then you will get proper lift. You see this picture, right side top left corner, you see this axis is here, but turbine blades are making certain angle, right, with axis. So these are actually angle of attack will be here. Okay, so that proper angle of attack design engineers will be considering. So they will try to maintain proper angle of attack. If there is no proper angle of attack, it will get very low lift or very low energy or lift will be producing, or it will give quickly lift will be almost zero. Okay, so in this airplane will be falling, or your turbine will not have proper power output. For air, whenever we are getting any force from turbine, we call aerodynamic force. For water, we are getting force, we call hydrodynamic force. Okay. And shape of airfoil, it can be symmetric. Symmetric means like upper surface and lower surface, pressure surface and suction surface, both will be same, like mirror image. Draw a chord line, uh, and upper and lower, you see chord line is mirror, then upper and lower will be same. So it's called symmetric airfoil. And if I don't have such thing, I have curved like thing, then asymmetric, asymmetric or cambered airfoil. So cambered airfoil is generated to get more lift. Stalling. Okay, so whenever airfoil is moving in air, okay, I told already one line is there, chord line, another line will be there, cambered line. Cambered line is average, the distance between top surface and bottom surface will be same, and it will be also curved, but chord line is straight line. Okay, now initially let's say you maintain certain angle of flow, okay, alpha, then fluid is touching the whole surface. Okay, is touching whole surface. When fluid is touching whole surface, actually you will get more torque or more power or more lift. But if you increase angle of attack or increase flow velocity, what in that case what will happen? After a certain time, fluid will not able to touch the surface. So there will be one vortex creation here. So vortex creation means fluid is trying to touch but it's unable to touch. So what will happen? It will not get proper lift. Okay, so when proper lift is not there, then there can be destruction or low torque you can get. Okay, and airfoil gives maximum lift in a given airspeed is limited by its boundary layer separation. It's called boundary layer separation. Okay, when boundary layer separates, when angle of attack increases, a circulating flow creates. Okay, so boundary layer separation will be occurring when angle of attack increasing or flow velocity is too high. So in that case, a circulating fluid will be created. Okay, so that fluid will not give enough lift. Okay, this is called stalling. This condition of boundary layer separation and creating vortex is called stalling. At angle of attack above this value, lift will be dropped. So lift coefficient formula, lift coefficient formula CD. Okay, L is called lift force. Lift force L equals half rho V square SCL. Okay, lift force. This is lift coefficient CL. Okay, air density rho density V equals air velocity or airfoil velocity, S the planform of the projected area, that whole area, how much area it is covering, that's called planform of the projected area. Lift coefficient already I have written CL. CL is the lift coefficient. So drag coefficient CD. Okay, so if I have any spherical body and fluid is flowing over it, so my CD value will be 0.47 CD equals. If I have semicircle like this, hemisphere, okay, so in that case CD will be 0.42. I have square, so CD will be 1.05. I have symmetric airfoil, so 0.04. Okay, so CD drag force equals to drag force FD rho U square A. So okay, FD is lift force L, so FL I should write. Okay. So is the reference area, U is the flow speed, you can write V, flow velocity, and rho air density. Okay, so this is the formula for CD, lift force and drag force. FD is a drag force, FD drag force.